Hi everyone, welcome to another video from defaultroot.co.uk. Today I'm just going to take some time out to have a look at a problem that was dropped into the IEOC, Internet Network Expert Online community today, and I picked it up and I thought it was really interesting, so I took a little time out to do a demo of it and just to demonstrate the situation this engineer was having at the time. So just to cover off the scenario, we have we have three routers, R1, R2 and R3, and what the guy said was he has area 1, OSPF area 1 covering R1 and R2, and another area called area 3 between R2 and R3. And what this chap's done is he's created two OSPF processes in R2. One of the processes is connected to area 1 and the other process is connected to area 3. And the problem that he's seeing is when he looks at the routing table, he's only seeing one E2 route with a 20 metric on it, and he's wondering why the inter-area route for this network that he's looking for isn't overriding the E2. Why is the E2 winning when actually an external route is considered less favorably than an inter or intra area route? So very interesting subject. So I've built a topology that you can see and run up some configuration. So basic configuration so far is R1 has a running OSPF process 1. We've got the network 150.1.12.0 statement added to the OSPF process. It's got a router ID of 1.1.1.1. and that's up and running, and we're also redistributing a loopback 10 interface that I've created on R1, which covers off the 10.10.10.0/24 network that this guy's trying to basically get into the R2's routing table. And then on area 3 here, on router 3, we've got another OSPF process running on 3. So router OSPF 3. Again, we've got a loopback address as the router ID 3.3.3.3. It's connected to the network 150.1.23.0/24, which is in the OSPF process. And there's also a loopback 10, but in this case, instead of redistributing the loopback interface, we're just adding it into the OSPF database with the network keyword. So it's going to turn out to be an intra-area route on R2. Or basically, R2 should see it as a normal OSPF route, because obviously it's not inter-area to R2 because it's connected to area 3. So let's have a look at what we did. So on R2, what I'm going to do now is I'm going to configure two OSPF processes, and we're going to have a look at creating an OSPF process 1 to connect to R1 and an OSPF 3. An OSPF process 3 connected to R3. We'll configure the local subnet of each link with the correct OSPF area, and we're going to see how the E2 route from area 1 looks and how the inter-area route from R3 looks. So let's go straight ahead and let's configure OSPF on R2. So first of all, we'll create OSPF process 1. We'll give it a network statement for the locally connected subnet. So network 150.1.12.2.0.0.0.0 area 1 is the host-specific OSPF entry there. So we've just brought that up. You can see the process is loaded to full. That's because we've already connected R1. So now onto OSPF 3. We'll put in the network statement. That's for the local subnet. We'll put that into area 3. And now we see area 3 comes up because I've already configured R1 and R3. So let's have a look at the OSPF neighborships. We've got 3.3.3.3, which is R3, and 1.1.1.1, which is R1. Here's this routing table, and you can clearly see that the 10.10.10.0 is the E2 route from area 1. So this is what the guy was talking about. So why have we got the E2 route with priority over the inter-area route? So on R1, we're just going to show you the OSPF configuration we've got there. You can see the two network statements, they're both in area 1, and there's the redistributed connected subnets statement, which basically redistributes the loopback 10 interface. There's the route map, and you can see it's matched on this access list 10 with 10.10.10.10 with the wildcard mask there. So now let's go on to R3 and show you the OSPF configuration on this one. So show run, and we'll do the section OSPF. So again, there you see three network statements this time, not redistributed, just brought into the OSPF database with the network statement we'll do a show run of the loopback, and you can see the IP address there and the Ospf network type, just so we get the correct mask there, not the host mask. So let's just go back to R2, show an IP Ospf database. You can see there a Type 5 AS external link from Area 3. Now that's not what we did. We configured a network for Area 3, so I don't know why that's a Type 5. And if you look at Area 1 here, we've got again the 10 as a Type 5 external, so that's correct. We did configure Area 1 as an external. But you know, why is there an external link from Area 3 when clearly we configured a network statement? If you look up and down on this output here, you'll see that there is a lot of matching here. The age, the sequence number, and the checksum tag seem to match. And so let's just have a look at that. We'll just zoom down into the 10.10.10.0 here, and so you can see it's got two external routes there, one from Area 3 and one from Area 1, but both look absolutely identical. So this is where we're saying Ospf looks like it's broken, right? We should not be seeing both learned from there. And the problem is we've got no Ospf Area 0, so without an Ospf Area 0 or backbone area, Ospf won't work properly. So we're going to tear down the configuration here. We're going to create a brand new Ospf process 2. We're going to give it a router ID 2.2.2.2 because we're on R2. We'll put the network statement again that's connected to Area 1 and Area 3. So we'll just put that one in. Area 1's come up now, so that's the neighborship with R1. Here's Area 3. Let's just wait for the neighborship to load here. This one's taking some time. Okay, so we'll just do a ping here, try and stimulate the neighborship. The ping's okay. Let's just have a look at the Ospf neighbors here. So it's two-way, so it's starting to. There we go. So now we've got the full relationship. Okay, so let's just do a show IP Ospf database. Have a look at this. Is how it's looking now. So this should be pretty much as it was last time. We should have two networks for 10.10.10.10 of the Type 5 from R1 and the Type 5 from R3. Even though we haven't got a Type 5 in R3, we should still be broken, and we can see that that's the case. There we are with the database entry for R1. And we saw the Type 5 in Area 3 before as well. So that's because we're still broken. Let's configure the backbone area now. So let's just put the loopback, the local loopback on R2 into Area 0. So now we've got a backbone area, and let's now do let's have a look at for network 10, and we see 10 is via R3. So this is right now. So we've got a natural Ospf statement now, where it's inter-area because we're connected to Area 3, so that's why it's an O route, not an OIA. So that's all working great. So there we go. So we've got the 10.10.10.0 from R1. We've got a 10.10.10.0 from with the R2 loopback. That's because we're in Area 3. And if we just have a look at the route, we can see it's learned from Area 3. It's from router 3 there. So 10.10.10.0 is being advertised by R3. So let's go into R3 now, and we'll basically tear down the loopback 10 interface, so stop advertising the 10.10.10.0 network, just to see that. Let's see that disappear. There we go. And now the E2 route from R1 is now in the routing table. So fully working Ospf now, and so hopefully you can tell. You need the backbone area there. Without a backbone area, Ospf absolutely broken. But as soon as we put the Ospf, the backbone area 0 there onto our local loopback interface on R2, it all came good. Okay, so hopefully you got something out of this blog entry. Thank you for listening and watching, and I'll see you next time.